Hello everyone. Welcome to the class of Calculus and Differential Equations 21 MAT 11. Today I'll be discussing a topic in Module 2, Differential Calculus 2, and the topic name that I would like to discuss is Taylor series expansion of one variable. Myself, Dr. Madhura, Assistant Professor, Department of Mathematics, Sai Vidya Institute of Technology, Bengaluru. Let us begin with differential calculus 2. Differential calculus 2. So here we'll be discussing many topics, and the first topic that we'll be discussing is Taylor series expansion of one variable. Taylor series expansion of one variable. So first let us write down the formula for Taylor series expansion of one variable. Taylor series expansion of f of x. Taylor's series expansion of f of x about the point x is equal to a is given by f of x is equal to f of a plus x minus a into f dash of a plus x minus a whole square divided by 2 factorial into f double dash of a, etc. The same is alternately written in the form of y of x. So y of x is given by y of a plus x minus a into y1 of a plus x minus a the whole square divided by 2 factorial into y2 of a. The next term would be x minus a the whole cube divided by 3 factorial into y3 of a, etc. Where y1, y2, y3, etc. are all derivatives of y with respect to x. Where y1, y2, y3, etc. are all derivatives of y with respect to x. So we'll be taking successive differentiation of y terms with respect to x to find out y1, y2, y3, etc. So this is the first topic what we will be discussing, that is Taylor series expansion of f of x about the point x is equal to a. So sometimes you might also use it in the form of f of x is equal to f of a plus x minus a into f dash, etc. I'll be using the alternate formula given by y of x is equal to alternate notation actually. So y of x is equal to y of a plus x minus a into y1 of a plus x minus a whole square divided by 2 factorial y a, etc. So while doing problems, until what degree terms we are asked to find out, we'll be working out or finding out the derivatives until those expressions. So let us do problems on Taylor series expansion. Taylor series expansion. Problems. First question. Obtain the Taylor's expansion of log x to the base e about x is equal to 1 up to the terms containing fourth degree. Hence obtain the value of log of 1.1 to the base e. Log 1.1 to the base e. So we need to find out the Taylor series expansion of the function log x. So here we'll be considering the function y of x, y as a function of x as log x. It is to the base e, means natural logarithmic. And we need to find out the Taylor series expansion about the point x is equal to 1. And we need to expand the series until 4th degree terms. So we will have to find out y1, y2, y3, y4. So that gives us 4th degree term. So 4 times we have to differentiate the given y of x with respect to x. And we have to substitute each value of y1, y2, y3 at the point x is equal to 1. We have to find out the value, substitute into the Taylor series expansion formula. So let us do the solution. First we will write on the formula. Taylor series expansion about the point x is equal to a is given by, we'll write on the formula first. Y of x is equal to y of a plus x minus a into y1 of a plus x minus a the whole square divided by 2 factorial y2 of a, etc. We have to actually write down until 4th degree term. Now we will substitute the value of a. It is given from the data. We have x is equal to 1. So x is equal to a is compared with x is equal to 1. So a value is equal to 1 we have to take. And we'll rewrite this formula with a equal to 1. So y of x is given by y of 1 plus x minus 1 into y1 of 1 plus x minus 1 whole square divided by 2 factorial into y2 of 1, x minus 1 whole cube divided by 3 factorial into y3 of 1 until 4th degree term. So one more term we will include, x minus 1 whole power 4 divided by 4 factorial into y4 of 1. So this is our required formula until 4th degree term. So let us call this as equation 1. We will be finding out all the values, that is y of 1, y1 of 1, y2 of 1, y3 of 1 and y4 of 1, and we will substitute into equation 1 to obtain the required Taylor series expansion for log x to the base e. So let us move ahead. Now let us denote first the function y of x by log x. So y of x is given as log x to the base e. To the base e indicates the natural logarithmic for us. So let y of x is equal to log x to the base e. So with this we have to find out y of 1. So let us find out y of 1. Y of 1 is log 1 to the base e. And we recall the standard value of log 1, which is equal to 0. Now we need to differentiate y term with respect to x. So y of x is given as log x. Log x differentiation is 1 by x. So what will be y1 of x? It will be 1 divided by x. Differentiation of log x is nothing but 1 by x. And with this we will have to find out y1 of 1. So y1 at the given point 1 we have to find out. So we will substitute y1 of 1. So this will be 1 divided by 1. This is a function y1 of x for us. In place of x we take 1 because that is a given point for us. So with that we will obtain 1 by 1, which is equal to 1 itself. Now we will have to find out the next differentiation. We are going to continue this until 4th degree. So y2 of x is equal to differentiation of 1 by x is minus 1 divided by x square. This is using the formula of differentiation of x power n is n into x power n minus 1. So using that formula we can obtain differentiation of 1 by x as minus 1 by x square. Now at the given point, that is at x is equal to 1, we will find out y2 of 1. So this is minus 1 divided by 1 square, which is minus 1 itself. Next, again differentiation, y2 of x we are going to differentiate to obtain y3. So y3 differentiation, the next differentiation, that is y3, is obtained as differentiation of minus 1 by x square will be 2 divided by x cube. 2 divided by x cube. It is again using the formula of differentiation of x power n is n into x power n minus 1. So x power minus 2 we will have, differentiation of minus x power minus 2 will be plus 2 into x power minus 3, which comes to the denominator and gives us 2 divided by x cube. So this is how we obtain y3 of x. Now at the given point we will find out y3. So we have y3 of 1 is equal to 2 divided by 1 cube, which is equal to 2. 2 divided by 1 cube, which is nothing but 2. Now finding out y4, the next differentiation and the last differentiation to find out. Because we are asked to find out until 4th degree term, we had already written the formula by substituting x is equal to point A, which is equal to 1. We have already obtained equation 1. And when you observe, we have to write down the degree terms up to y4 of 1. So let us find out y4 of x first, followed by y4 of 1. So differentiation once again with respect to x, 2 is a constant. Differentiation of x power minus 3 will be minus 3 into x power minus 3 minus 1, which is minus 4. So we already have a 2 here. So this becomes minus 6 divided by x power 4. Minus 6 divided by x power 4. So now we will find it out at the given point, that is x is equal to 1 we have to take. So y4 of 1 is minus 6 divided by 1 power 4, which is minus 6. Now just for convenient, I will block all these answers. These are our obtained values, that is y of 1 is 0, y1 of 1 is 1, and then we have y2 of 1, which is minus 1, then y3, which is 2, y4 of 1 is minus 6. So these are our required values which we will substitute in the formula, that is equation 1. So substituting these values in equation 1, we are obtaining y of x as log x to the base e. So let us substitute the left hand side as log x to the base e itself. So log x to the base e is equal to, we are substituting y of 1 as 0. So first term vanishes for us and we have next term substitution, that is x minus 1 into y1 of 1. y1 is 1. So we have x minus 1 plus x minus 1 the whole square divided by 2 factorial, which is 2, into y2 of 1. y2 is minus 1 plus x minus 1 the whole cube divided by 3 factorial is 6 into y2 of 1. y3 of 1, which is nothing but 2, and the next term will be x minus 1 the whole power 4 divided by 4 factorial is 24 into minus 6, that is y4 of 1. So we substituted all the values. Now we simplify this expression. We'll simplify the constants, numerator, denominator. So we have 2 1s are 2 3s and the third term, and we have 6 1s are and 6 4s are in the fourth term. So simplifying these things, we can obtain log x to the base e is equal to x minus 1 minus x minus 1 the whole square divided by 2 plus x minus 1 the whole cube divided by 3 minus x minus 1 the whole power 4 divided by 4. This is up to 4th degree term. This is the required expression for log x to the base e using Taylor series expansion about the point x is equal to 1. Now in this equation, we have to substitute x is equal to 1.1 to find out log of 1.1 to the base e. So let us substitute log 1.1 to the base e. So substituting x is equal to 1.1. We can obtain an answer for log 1.1 to the base e. So in the RHS also, wherever x is there, substitute x as 1.1. So this will be 1.1 minus 1 minus of 1.1 minus 1 the whole square divided by 2, 1.1 minus 1 the whole cube divided by 3 minus 1.1 minus 1 the whole power 4 divided by. So you can just take up a calculator and we can solve this. Using the calculator we can obtain the answer for this. Log of 1.1 to the base e is equal to, we get, this is approximately 0.0953. We have rounded off our answer to the third decimal place. 0.0953, and we have rounded off our answer to the third decimal place. So this is how we can obtain the Taylor series expansion of the given function f of x or log y of x, and up to what degree terms we are asked here. We were asked up to 4th degree term, and it was about the point x is equal to 1. And after evaluating the Taylor series expansion of log x, we had to take x is equal to 1.1 to obtain log of 1.1 to the base e. We'll see second problem now. Obtain Taylor series expansion of Taylor's series expansion of log of cos x about the point x is equal to pi by 3 up to 4th degree terms. So we need to obtain the Taylor series expansion of log of cos x about the point x is equal to pi by 3 and up to 4th degree term. So first let us write down the formula for Taylor series expansion, and we substitute a value as pi by 3 first, because we have to find out the Taylor series of the given function about the point x is equal to pi by 3, and then we find out derivatives of log of cos x with respect to x 4 times until 4th degree term we have to obtain. So solution, Taylor series expansion about the point x is equal to a is given by y of x is equal to y of a plus x minus a into y1 of a plus x minus a the whole square divided by 2 factorial into y2 of a, etc. Of course, we have to find out until 4th degree term. Now it is about the point a equal to pi by 3. So the formula can be rewritten as y of pi by 3 plus x minus pi by 3 into y1 of pi by 3 plus x minus pi by 3 the whole square divided by 2 factorial into y2 of pi by 3. The third degree term will be x minus pi by 3 the whole power 3 divided by 3 factorial into y3 of pi by 3, and the 4th degree term x minus pi by 3 whole power 4 divided by 4 factorial by 4 of pi by 3. So this is our formula. So we will call it as equation 1. This is at the point x is equal to a equal to pi by 3. Now we need to consider the given function, and we have to find out the derivatives with respect to x and at the given point as well. So let us do that. So let us assume y of x first. So y of x is equal to log of cos x. log of cos x, and we have to find out first y of pi by 3. That is the very first requirement for us, no? The very first term is y of pi by 3 for us. So y of pi by 3 gives us log of cos pi by 3. Log of cos pi by 3, cos 60 degree. Pi by 3 is nothing but 60 degree. So cos 60 degree is 1 by 2. So we will have log 1 by 2. This can be written as log 1 minus log 2. Using logarithmic property, log of a by b equal to log a minus log b. So this will be log 1 minus log 2. Log 1 value is 0. So we just obtain minus log 2 here. Minus log 2. Now we'll move ahead to find out the differentiation of y of x is equal to log of cos x. So we differentiate this to obtain y1 of x. Differentiation of log of cos x is 1 divided by cos x into differentiation of cos x is minus sin x. So we are getting this is minus tan x. So we have y1 of x is equal to minus tan x. So we will now find out at the point pi by 3. At the point pi by 3, we will find out what is the value for y1 of pi by 3. So y1 of pi by 3 will be minus tan pi by 3. We'll recall the value for tan 60 degree. Tan 60 degree is root 3. So we get here minus root 3 as the answer. There is already a minus sign. I have retained it as it is. And tan 60 degree is root 3. So we have minus root 3 as the answer for y1 of pi by 3. Now next we will move ahead to find out y2 of x. So differentiation of y1 of x gives us y2 of x. So y2 of x will be differentiation of tan x. Keeping minus sign as it is, differentiation of tan x is secant square x. Minus as it is, differentiation of tan x is secant square x. So now we will find out what is y2 of pi by 3. Let us find out y2 of pi by 3. y2 at the point pi by 3. So this will give us minus secant square pi by 3, and that is equal to minus 2 square. Secant pi by 3 is nothing but recalling the value of secant pi by 3 is 2. Cos pi by 3 is 1 by 2. So reciprocal of it gives us secant pi by 3, which is equal to 2. So we have minus 2 square, which is nothing but minus 4 for us. So this is y2 of x for us. Now for convenient, we can use the identity for secant square x. Secant square x can be written as 1 plus tan square x, and tan square can be written as y1 square. Because y1 of x is equal to minus tan x, we can simplify this just for the simplicity purpose and we can differentiate. This is just for convenient. Of course, not a compulsion. You can directly differentiate to find out y3 of x differentiation, and then y4 also you can directly do. So I prefer to substitute in the form of 1 plus tan square using the identity for secant square. So I will rewrite this as y2 of x is equal to minus of 1 plus tan square x. So that we can write down y2 of x as minus of 1 plus y1 square, no? Because we have y1 of x is equal to minus tan x, squaring on both sides, we can obtain y1 square is equal to plus tan square x. So we have a simple expression for y2, so the differentiation can be done easy. So this is only purpose of making the differentiation easy, not a compulsion. We will move ahead to differentiate this once again with respect to x, and we find out y3 of x now. So we have y3 of x is equal to minus of 1 plus y1 square differentiation we have to do. Differentiation of 1, which is a constant, is 0. So we have 0 plus differentiation of y1 square is 2y1 into y2. I'll explain the differentiation once. Differentiation of x square, it is similar to that. So differentiation of y1 square will be 2y1 into differentiation of y1 with respect to x. y1 stands for dy by dx. So differentiation of dy by dx will be d square y by dx square. So that is what we have written it here as y2. So we have y3 of x is equal to minus of 2y1 by 2. y3 of x is equal to minus 2y1 by 2. So that now we can find out at the given point. At the given point. So that is y3 of pi by 3 is equal to minus 2 into y1 at the point pi by 3 into y2 at the point pi by 3. That will be the meaning actually. Right? Both y1 and y2 we are finding at the given point pi by 3. We have already found out y1 of pi by 3 and y2 of pi by 3. We substitute the same thing to obtain the answer for this. So minus 2 into y1 of pi by 3 is nothing but minus root 3 and y2 of pi by 3 is nothing but minus 4. So there is 3 minus signs. So this will be minus 8 into root 3. Minus 8 root 3 will be the simplified answer for y3 of pi by 3. y3 of pi by 3. Now next we will move ahead to obtain y4 of pi by 3. That is, we have to differentiate once again y3 term. So we have y4 finally now. y4 of x is equal to minus 2 into, we have to apply product rule for y1 into y2. So y1 into differentiation of y2 is y3 plus y2 into differentiation of y1 is y2. So we have y4 of x as minus 2 y1 y3 minus 2 y2 square. Correct? I'll explain this once again. So we are applying product rule for minus 2 into y1 into y2 and we differentiate to obtain the next differentiation, that is y4 of x. So we have written minus 2 as it is, differentiation of y1 into y2 by applying the product rule. First we will keep y1 as it is, differentiation of y2 with respect to x is y3 plus y2 as it is, differentiation of y1 with respect to x is y2. So we have multiplying minus 2 inside, it is minus 2 y1 into y3 plus into minus minus 2 into y2 gives us y2 square. y2 square. Now at the given point, let us find out y4 of pi by 3. So we have y4 of pi by 3 is equal to minus 2 into y1 of pi by 3 into y3 of pi by 3 minus 2 into y2 of pi by 3 whole square. So let us substitute all the known values. We are already familiar with what is y1 of pi by 3, y2 of pi by 3, and we also obtained y3 of pi by 3. So let us substitute all the values to obtain y4. So we have minus 2 into y1 of pi by 3 is minus root 3 into y3 of pi by 3 is the previous value what we obtained, minus 8 root 3 minus 2 into y2 of pi by 3 we have obtained already, which is minus 4. So it is minus 4 the whole square. So this on simplification, there is 3 negative terms. This is the entire product we have to do here. So minus into minus into minus, and we have 8 into 2, 16, root 3 into root 3, root 3 into root 3 is 3. So we have 8 2s are 16, 16 into 3, 16 3s are 48. Minus 4 whole square gives us 16, 16 2s is 32. So we have minus 32. Minus 32 minus 48 gives us minus 80. 80. So these are our required answers, what we have already obtained. I'm just marking that for you. So we had already obtained the y1, y of pi by 3, y of pi by 3, which is minus log 2 for us. Then we had y1 of pi by 3, which is minus 1, minus root 3. Then y2 of pi by 3 is minus 4. Then in the next page, we have answers for y3 of pi by 3 and y4 of pi by 3. So y3 of pi by 3 is minus 8 into root 3. And similarly, y4 of pi by 3 is minus 80. Minus 80. So these are the required values which we need to substitute now in equation 1. So we will substitute in equation 1 to obtain the Taylor series expansion of the given function, that is log of cos x. Substituting in equation 1. Substituting in equation 1, log of cos x, y of x is nothing but log of cos x for us is equal to, we will substitute term by term. So first term is y of pi by 3 value, which is minus log 2. Minus log 2 is the first term for us. Plus x minus pi by 3 into y1 of pi by 3, which is minus root 3. X minus pi by 3 into minus root 3 plus x minus pi by 3 the whole square divided by 2 factorial into y2 of pi by 3. y2 of pi by 3 is minus 4 plus x minus pi by 3 the whole cube divided by 3 factorial is 6 into minus 8 root 3, and the last term x minus pi by 3 the whole power 4 divided by 4 factorial is 24 into minus 80. Now let us simplify the fractions that we have to the simplest form and we rewrite the answer one step. So we have 2 factorial as 2, so 2 ones are, and then this multiplies to 2 twos are, and here we have 8 divided by 6, so 2 4s are and 2 3s are. Here we have 80 divided by 24. So it is maximum multiplier that can take here is 8. So 8 10s are and 8 3s are. So this is how we can simplify and rewrite the answer. So therefore, Taylor series expansion of log of cos x is minus log 2 plus into minus minus root 3 into x minus pi by 3. And again plus into minus is minus 2 into x minus pi by 3 whole square. Again there is a minus sign. Minus 4 divided by, can this be written as root 3 into x minus pi by 3 whole cube. And the last term is minus 10 by 3 into x minus pi by 3 the whole power 4. So this term, fourth term, I wrote it as 4 divided by 3 into 4 root 3 divided by 3 is what actually we have. And denominator 3 can be written as root 3 into root 3, so that one root 3 gets cancelled. And thus we can write it down as 4 divided by root 3. So this is the required Taylor series expansion for the function log of cos x. We'll see third problem on Taylor series expansion. Expand tan inverse x in powers of x minus 1 up to the term containing third degree. Up to the term containing third degree. So we have to expand the function tan inverse x in powers of x minus 1. So when they give it to you as in powers of x minus 1, you have to obtain the answers at last in the powers of that. That is x minus 1 whole power 1, x minus 1 whole square, x minus 1 whole cube, etc. terms you should have. So in order to have x minus 1 powers, your point A equal to 1. So you have to obtain the Taylor series expansion of tan inverse x about the point x is equal to A equal to 1. So it is indirectly mentioned the point A here. So we have to obtain until third degree term. Until the third degree term, we need to obtain the Taylor series expansion. So let us see the solution now. First, we will write on the formula Taylor series about the point x is equal to 1 is given by, first we will write on the general formula and then we substitute x is equal to A equal to 1. So y of x is equal to y of A plus x minus A into y1 of A plus x minus A the whole square divided by 2 factorial y2 of A, etc. So we need to obtain at the point x is equal to A equal to 1. So we have to write down y of 1 plus x minus 1 into y1 of 1 plus x minus 1 whole square divided by 2 factorial y2 of 1 until third degree term. So let me also mention that third degree term for you. So it will be x minus 1 whole cube divided by 3 factorial into y3 of 1. y3 of 1. So this is our formula where we have to find out all the derivatives and substitute at the point 1 in this equation 1. Now let us call the given function tan inverse x as y of x and find out the derivatives one by one. So let y of x is equal to tan inverse x. Now we have to find out at the point 1. So let us find out at the given point 1. So y of 1 is equal to tan inverse 1. Tan inverse 1 is equal to pi by 3. Pi by 4, 45 degree. Tan inverse 1 is equal to pi by 4. So we will now continue finding the next derivative. So that is y1 of x. Differentiate y of x with respect to x. So y1 of x is equal to differentiation of tan inverse x. Differentiation of tan inverse x is 1 divided by 1 plus x square. 1 divided by 1 plus x square. And we will have to find out at the given point now. So we find out y1 of 1. So 1 divided by 1 plus 1 square. Wherever x is there, substitute the point A value which is equal to 1. So this gives us 1 divided by 2. 1 plus 1 square this is. So 1 divided by 1 plus 1 square gives us 1 by 2. Next we will find out the next derivative, that is y2 of x for us. Before finding y2 of x, for convenience we can cross multiply this to the left hand side so that we can apply product rule. We can avoid using the quotient rule, and that is the reason I just cross multiply this term to the left hand part. So we actually have 1 plus x square into y1 of x. I'll just simply write it down as y1 is equal to 1. Now we differentiate this once again with respect to x to obtain y2 of x. We need to apply product rule left hand side. So 1 plus x square into y2 plus y1 into differentiation of 1 plus x square is 2x is equal to differentiation of a constant in the right hand side is 0. So let me explain once again the differentiation for you. So we have 1 plus x square into y1 is equal to 1 after cross multiplying this term, and we differentiate with respect to x. So product rule has to be applied. First we keep 1 plus x square as it is, UV rule, and then differentiation of y1 will be y2 plus y1 as it is, differentiation of a constant 1 will be 0 plus x square differentiation will be 2x. So 0 plus 2x gives us 2x. And right hand side it is differentiation of a constant, that is 0. Now at the given point we have to find out. So wherever x is there, substitute x as 1. Before doing that, just for convenient, I will rewrite this y2 from this, so that y2 at the given point can be easily found out. So this can be written as y2 of x is equal to minus 2xy divided by 1 plus x square. This is just shifting the terms. So first we shift 2x y1 to the right hand side. So we have minus 2x y1 to the right hand side. And then we have divided by 1 plus x square. So this is the expression for y2 of x for us. Now we will find out y2 at the given point. So minus 2 into 1 into y1 value is 1 by 2, the whole divided by 1 plus 1 square. So on simplification, this gives us minus 1 by 2. Minus 1 by 2. 2 get cancelled. So we have minus 1 in the numerator, denominator it will be 2. Now, in order to find out the next differentiation, we have an expression with respect to y2. One last differentiation, that is y3 is to be obtained. So let us obtain y3 after differentiation. So differentiating once again the left hand expression of y2 whatever we have with respect to x, again product rule. So 1 plus x square into y3 plus y2 into 2x plus 2x y1 also has to be applied product rule. The second term 2x y1 also has to apply product rule. So 2x into y2 plus 2y1 into 1 equal to 0. So we have 2xy2 and 2xy2 in the middle two terms. So we can just add up these two and rewrite the expression, and we get 1 plus x square into y3 plus 2xy2 plus 2xy2, which gives us 4xy2 plus 2y1 is equal to 0. And just for simplicity again, I can write down this expression for y3 and obtain y3 at the given point 1. So this gives us y3 of x is equal to minus 4xy2 minus 2y1, the whole divided by 1 plus x square. So that y2 at the given point will be, so therefore y2 of 1, which will be equal to minus 4 into 1 into minus 1 by 2 minus 2 into 1 by 2, the whole divided by 1 plus 1 square. I'll just show you the substitution step here. So we have minus 4xy2. So minus 4 into x value is 1 into y2. y2 at the given point is minus 1 by 2, which we already obtained. So minus 1 by 2. And there is minus 2y1. Minus 2 into y1. So minus 2 into y1 at the given point is 1 by 2. So 1 by 2. The whole divided by 1 plus x square. X is 1. So that is by 1 plus 1 square. Now let us simplify this. We have 2 1s are, 2 2s are. And this is plus 2 and minus 1. 2 minus 1 is 1. So are we getting 1 by 2? Correct, no? So we obtain 1 by 2 at this stage here. So these are our required values of the differentials at the given point x is equal to 1. So just for convenient, I am blocking all those answers for you. So we have y of 1 is equal to pi by 4. y1 of 1 is 1 by 2. y2 of 1 is minus 1 by 2. And now finally we obtained y3 of 1 as 1 by 2. Which is there in the next page for us. Now we substitute all these expressions into equation 1 to obtain the required Taylor series expansion of the given function tan inverse x. So substituting these values in equation 1, tan inverse x is equal to, the first term will be pi by 4 plus x minus 1 into 1 by 2 is 1 by 2 because y1 of 1 is 1 by 2 plus x minus 1 whole square divided by 2 factorial into y2. So next term will be x minus 1 whole square divided by 2 factorial into y2. y2 is minus 1 by 2. And again the last term x minus 1 whole cube divided by 3 factorial is 6 into 1 by 2. So you can just rewrite the answer. We take 1 by 2 common in the last three terms. So if I take 1 by 2 common, we remain with x minus 1 minus of x minus 1 whole square divided by 2 or 2 factorial can be retained as it is, anything is okay. So x minus 1 whole cube divided by 3 factorial. So this is the required Taylor series expansion of the given function tan inverse x up to third degree term about the point x is equal to a equal to 1. So these are the problems about Taylor series expansion. Thank you for watching.